Hey, so I'm here to present to you the methods and solutions for flood management/containment by Izoduwa Ighodaro, Tracy Chen, and Anna Dinh. Abstract. Our project will research and create an effective buildable system in which we are able to manage and prevent the clogging of storm drains that causes flooding on the streets. In addition, we will research and draft other methods that can reduce flooding and mitigate the effects of it on our cities and towns. So our question for our project was, how can we further improve the efficiency of storm drains and flood management methods as a whole? We came up with our hypothesis, which was our storm drain design will manage and better prevent the clogging of storm drains compared to the current system we have in the streets of the United States. Our research methods will be able to mitigate the effects and levels of flooding. So this section of our PowerPoint will show you our storm drain design and also some background information about storm drains already present in the United States. Urban stormwater collection and conveyance systems. So what this slide is essentially saying is, how do storm drains work? Well, storm drains, they take water present on the street and drains it out into underground water systems. The gated opening, as you can see on the right, keeps the leaves, debris, and trash out of this underground system, which allows the water to run smoothly through. So what is the flaw in our present systems? Well, once these storm drains get clogged by bigger pieces of trash or debris, they're virtually ineffective. Once they are clogged, they have to be physically unclogged by a person, and most cities won't do that quickly and effectively, which will cause many accidents and flooding. So how do we fix this? Since the main issue is the clogging of the storm drains, we decided to design a better and self-cleaning system. So this is our design proposal. Our design will consist of 2 matching bars, a scanning mechanism, a water pressure detector, and a lifter. The 2 matching metal layers will be designed similar to the ones already present in the United States. They will be a matching pair, which will allow it to function normally and have water smoothly run through. The water pressure detector will notify the scanning mechanism if the water pressure suddenly drops. This will be the first sign of potential clogging. The scanning mechanism will then scan the layers to detect objects clogging the drain, and if it senses something, it will alert our system. The first layer will then lift up, taking the debris with it, allowing enough water to decrease the water level some, if not completely. The reason we have 2 layers is to minimize the margin of error and to protect our systems efficiently. So this is a visual representation of our project. On the top left, you can see a visual representation of our storm drain design. So there's a top and a bottom layer, which is very different from the single layer storm drain designs we have currently. The scanning mechanism will then scan the top layer if it senses a drop in water pressure, and it will alert our systems. The system will then realize that the top layer is clogged and it will lift. The following part of our presentation will show flood prevention methods that will help us prevent flooding in the United States. So what causes flooding? To find a solution, we have to understand the problem. What is the main reason of flooding in the United States? Well, the main reason of flooding can be attributed to 2 main things: large amounts of water or failure of dams. Heavy rainfall or unusual high tides are an example of this. Failure of dams, levees, and spillway gates also cause large amounts of flooding. So after doing some research and looking at old past dams that collapsed, we found a running theme within all 3 of these. Overtopping, which is essentially water spilling over the top, was a main concern that happened, as well as cracks in the dam due to poor regulation. Heavy rainfall in these areas caused overtopping to spill water over the dams and prove them virtually ineffective. So after examining many floods caused by the Canyon Lake Dam, Mill River Dam, Austin Dam, and Buffalo Creek Dam, we found the following flood prevention methods. Constant review and updates of building codes and dams. Building dams taller to reduce overtopping, creating more spillway channels and floodplains for the excess amounts of water, strengthening and repairing walls over time to prevent erosion, keeping drainage systems clean and prevent them from clogging to allow water to easily flow through them, and having different levels of levees to prevent breaching. So that is the end of our presentation. Again, it was made by Izoduwa Ighodaro, Tracy Chen, and Anna Dinh.